The Chinese launched a spacecraft, docked with that other spacecraft and refueled it, and they burned 6 years' worth of fuel in 10 minutes. Completely changed the orbit and left the American satellites in their dust.
Hey, Space Watchers. Welcome back to Space Café Radio. This is Maria Varmazes from T-Minus Space Daily. And today, from Orlando, Florida, we're recording this episode with Daniel Faber, the CEO of Orbit Fab. I am here at Commercial Space Week in Orlando, Florida, and returning to speak with me this time in person is Daniel. Daniel, would you mind reintroducing yourself for our audience, please?
Absolutely. It's great to be back. Daniel Faber, the CEO of Orbit Fab. Gas stations in space is our game.
All right, and petrol stations in space alternately. Thank you so much for speaking with me again. So last time we spoke, you all had announced at that time a new expansion into the UK, and it sounds like that's been going really well. Can you give us an update?
Yeah, absolutely. It was now 3 years ago, perhaps 4, that we expanded into the UK. At the time, the UK Space Agency had written a strategy to make the UK the world leader in satellite servicing, and was bringing all of the satellite servicing companies to the UK. For us, providing fuel in orbit, it was obvious that our first customers, the ones that were going to use a lot of fuel, are the ones that are going to move a lot.
Right.
And if you're going to build a tow truck, you've got to go from satellite to satellite to satellite. And it's not going to work unless you can refuel it, because otherwise you're throwing away your shiny new tow truck after a couple of tows.
Yeah.
And so we had to be there because our customers were moving there. And we hired one person and said, see what you can make of this. We got a really good person in Manny Shah who had previously stood up Bryce Tech's office there. And so he knew what he was doing and really grabbed it and ran with it. Was able to win some contracts, took the resources that we gave him and built that up. And then his wife got a phenomenal job in the US. And so he told me one day that he was leaving when he got it up to about 8 people. But he also told me that he'd hired the chief of staff of the UK Space Agency.
Oh, that's not too bad.
To come on board and run Orbit Fab's UK office, which was absolutely brilliant. So Jake Gear is now the managing director of our UK office, and he's taken it to a whole other level. We now have 25 people in the UK. It's about a quarter of the company.
It's amazing.
And they've been doing great things. They pursued parallel technology. So in the US, we're focused on US government needs of hydrazine fuel delivered in geostationary orbit. In the UK, they focused on the fuels that are used most by the commercial satellite operators.
Oh.
So xenon and krypton, which are much higher pressure, very different characteristics, hard to pump and move them around. And they've been flight qualifying all of that hardware. Just signed a contract to build a fuel delivery vehicle for xenon for low Earth orbit with the European Space Agency.
Wow, congratulations on all of that. The technical challenge of that must have been fascinatingly difficult, for lack of better terminology.
Yeah, as an engineer, it's fun. The most difficult thing is understanding what it has to do. Because you're trying to dock satellites together in orbit, not something that's been done a lot.
No.
You're in a plasma environment with really harsh thermal differences between different parts of a spacecraft, let alone 2 different spacecraft. Because it's a plasma, the spacecraft are charging up electrostatically. They can be at tens of thousands of volts relative potential. And then they're coming into dock with some level of misalignment, impact energies and velocities and capture envelopes, and lighting conditions are rather difficult because there's no atmosphere. The sky isn't glowing. You get one harsh light source from the sun, and then you've got reflections off the other spacecraft and all these kinds of things. So you have to think about all of those things all together, all at once. That's as simple and small as possible and puts no imposition on the client. And then you move all the complexity over to the fuel delivery vehicle, and it's got to be able to do this reliably, repeatedly, with spacecraft built to completely different configurations by completely different manufacturers from different sides of the world. And so once we figured out those requirements and that interface, which took us years, but we were able to share that from our US office to the UK office. And so at least when they started working, they've got a higher pressure propellant with different characteristics, but a lot of the basics of getting the 2 spacecraft together, we could share that. We didn't even have to share the reasons and how deeply we went. I just share an interface specification, and they could build off that interface spec. So that allowed them to move a lot more quickly.
From an engineer point of view, a fascinating problem to solve. But backing up years ago, when you were looking at the scope of what you're trying to solve and build for, I'm sure you got a lot of that's not possibles, right?
It's not a new idea. The idea that it's possible wasn't really questioned. What was questioned was, do I need it? Do I need it now? Is the time now? It's a 40 or 50-year-old idea. Why hasn't it been done yet? And the answer is because everyone's always come back and said, oh, let's let somebody else worry about it. From our investors' perspective, think about the bet that I'm asking them to take, right? I'm going to have to go through all of this engineering challenge to figure out what I'm designing, right? I've got to design it, build it, test it, deploy it to orbit, prove that it's safe, and then people will buy a gas cap. And they'll wait a few years until they run out of fuel, and then they might buy fuel. So closing that business model with significant upfront capex and a very long time until revenue has previously been seen as impossible. And we hear at Space Mobility, and we're hearing speaker after speaker talk now about how critical it is to have refueling. And yet there are some high-ranking generals saying we've run the war games and I still don't get it. They're in a paradigm. They've become very good at operating with one tank of fuel, and to change that paradigm is hard. And so we're still running into that 5 or 6 years after we set up the company, after we've flight qualified all the systems, after we've deployed the first fuel depot in orbit, and we still get that question, is now the right time? And we're pretty confident we can solve it. Think about docking two spacecraft together. I got self-driving spacecraft here that come together in that environment that I described and are able to reliably dock together. One of the reasons that we can feel pretty confident about that is because billions of dollars have gone into self-driving cars, and the compute systems have improved, the algorithms have improved. There are a lot more people with that expertise. We can just borrow that. Right? It's a great place to start.
Yeah, and repurposing.
It's the same but different. Yeah. So now we have self-driving spacecraft. Yeah. And the technology does move, and that helps. From the beginning, we were confident that we could do the engineering. It's just a matter of money and time. What we had to get comfortable was that someone was actually going to care enough to pay for it.
Going back to your point about hearing top brass in the military going, I don't understand it as much. I'm also hearing a lot of people going, I do understand it.
That has definitely changed over the last 5 or 6 years. It's gone from a few people saying, yeah, we're going to need this soon, to now only a few people saying, now might not be the time. It's completely flipped in the ratios of people that get it. And this conference has now been running for 3 years. The existence of Space Force was a reaction to the realization that space is a contested environment. And so the big question Space Force has right now is just, are we only caring about serving people on the ground, making sure they have comms and remote sensing and all those kinds of things? Or do we actually care about protecting those assets in orbit? And every day space becomes more contested. It's fairly clear that the job of Space Force is going to become more and more dominated by keeping those assets on orbit alive and active and able to provide the services which have frankly become completely indispensable to economies on the ground as well as national security on the ground.
I just think back the last 3 years, how much I've heard from it would be nice to this is a necessity. That shift has been very clear. I'm also curious about the other markets that you all are looking at. You mentioned the European Space Agency. Is that an area of huge growth for you all, or is that an area you're going to be focusing on?
Absolutely. So this market's going to be driven initially by national security concerns, right? It's absolutely imperative that aligned Western nations have this capability, that they're interoperable. These things matter. 6 months ago, the Chinese did the first refueling in orbit. And it's not 100% clear whether they refueled or just attached a jetpack. But either way, they had a satellite that was being quite active on orbit. It was checking out other satellites. They actually grabbed a satellite and moved it and put everybody on notice they had this capability. And so the US had drifted a couple of satellites over to check out what it was doing. The Chinese launched a spacecraft, docked with that other spacecraft and refueled it, and they burnt 6 years' worth of fuel in 10 minutes. Completely changed the orbit and left the American satellites in their dust. And we could follow them, but if we burn 6 years' worth of fuel, we've just lost 6 years off the back end of the mission. And the Chinese, because they can refuel, will probably just do another burn. And you can follow them the second time, you've got zero fuel left. You're gone. And so the decision had to be made that we can't afford to follow them, which means that we've already been completely outmaneuvered in orbit. It's just shocking this situation has come about when the US needs to be leading. We need to be the ones providing the deterrent on future conflict. And the US and aligned Western nations. Yeah. That's driving the imperative. Yeah. The good thing for the commercial industry and civil and everything else is that the advances we make on the back of funding for that imperative on national security, those advantages then can help us grow the in-space economy and create all of the other things that a lot of us got into this industry to see happen.
I feel like I want to pick your brain a little bit about other parts of the space industry that you're especially intrigued about right now, because you are in such an interesting part of it yourself, not just you personally, but your company. I'm curious about what else you've got your eye on.
I think we mentioned last time we spoke, I got into this 25 years ago because I thought that getting humanity off Earth is going to be the most significant thing that's happened since we crawled out of the ocean. If you think about it, this is crawling off Earth into the solar system and into the galaxy. Why would I work on anything else? But in Australia at the time, there was no space agency. And so I wrote down a list of industries that I thought could pay for the first permanent job in space and started chipping away at everything related to asteroid mining. And so I've seen a lot of things in that direction. I've dug into space tourism, space solar power, in-space manufacturing. The Fab in Orbit Fab was because we started looking at semiconductor manufacturing. And then we pivoted hard. Now we do refueling. I've kept an eye on all of these things and been interested in where it goes. Mostly, the recognition is that we need a really thriving in-space economy that is constantly reducing the costs to do operations in space and increasing the economic benefits and opportunities. And at some point, you'll cross a threshold where we can either put people into space cheaply and cost effectively, and we can just pay to go there because we want, or we'll create a need and an imperative that it's just going to be more profitable to have people in space permanently. And at that point, we become interplanetary. And so everything that I'm looking at here, all these things I've mentioned are economic reasons, drivers, profit incentives to have more activity in orbit. So while we're working on fuel, I boil that down and said, today I need to build a gas cap, because it doesn't exist, and that's what's going to unlock things. Now we've got the gas cap, right? So now I need to build fuel delivery vehicles and fuel depots and an infrastructure that brings the capability to bear. And other people would build on that to build the servicing vehicles. So we can then robotically do assembly and upgrades and repairs. At the moment, no satellites interact in orbit. The last thing you want to hear is that someone's going to come and poke your satellite. We need that to be not just common, but accepted, understood, desirable, a part of the standard operating procedure. It's going to be so much cheaper to upgrade satellites and not have to launch the structure, the pointing controls, the power, the thrusters. The only thing that's on Moore's law is the transponders or the instruments. Let's just replace the instruments. It'll save us 90% of the launch mass. And driving that cost down will mean that demand will go up by 100-fold. Everyone's going to benefit from that cost coming down, but that infrastructure in orbit starts to do it. And that will start to unlock larger facilities, asteroid mining, tourism manufacturing. All these things are going to need an industrial chemical supply chain, the ability for spacecraft to interact in orbit, all these kind of things. So I'm extremely bullish about where the industry's going. And frankly, we really lucked out being that industrial chemical supply chain and happening to work on something so critical.
You mentioned a little bit about some future plans. I don't know if that was maybe at the beginning of our chat or a little earlier. I just wanted to make sure I asked you about what's coming up next. What's on the radar for you all?
I mentioned we've got all the hardware flight qualified. We're on contract to deliver fuel for the US government end of this year or early next year. We've got 4 systems total going up to deliver fuel to multiple clients, including now in Europe, the delivery of Xenon to low Earth orbit. So executing on that is the highest priority and really perfecting that technology and building out the operational architecture and infrastructure. Because while we have all the equipment going up, it's all minimum viable product. We need to scale that. But looking beyond that, some of the things that we're interested in is transitioning from a company that does storage and delivery into a company that does refining, storage, and delivery. It looks a little like oil and gas, right? So I don't want to become an asteroid mining company, not with Orbit Fab. I don't want to become a shipping company. I don't want to do orbital transfer vehicles. I don't want to become a servicing company. But I'd like to be the biggest customer of asteroid or moon mine material. So this starts off by launching from the ground one inert, simple feedstock that's easy to get into orbit, water or something similar, and then turning that into a range of products that I'm already selling and already have a market for. So on the propellant side, I could launch water and turn it into hydrogen peroxide, hydrogen, oxygen, or water. Right? I've got 4 products for one storage facility of water. There are other chemicals that we're looking to produce, but that's the thin end of the wedge that gets us to fully refineries and processing asteroid material.
So then in that way, you would be almost a customer of another company that would be potentially doing some sort of asteroid mining and feeding back into the space industry there.
Yep.
Yeah.
The biggest problem with asteroid mining, of all the risks that they have, geology, technology, is no one's buying.
Indeed. I've often heard that too. And people go, it sounds cool, but who's going to pay for that?
So what I'm trying to build is the market.
Is there anything else that you wanted to share with the audience today before we close out?
What Orbit Fab is building is, we think it's fun and absolutely critical, and if we didn't think it was the most important thing that needed to be worked on, we wouldn't. But there's so many other people building pieces of infrastructure that are really important. And we don't build spacecraft buses, we buy them. There's a lot of companies that are working to build lower cost spacecraft buses in greater quantity and everything else. We don't build the guidance and navigation, the rendezvous and docking, we buy that too. But that's a critical product and needs to be productized and brought to market and matured so that everyone's comfortable with spacecraft docking and zipping around each other. There's other technologies that are being developed now that are coming online in the next couple of years that, when looked at together, produce enormous opportunities, ways to rewrite the current business model. I described how you could upgrade a satellite.
Yes.
Currently, if you want to do a global telecommunications constellation, you do a design of a highly integrated and optimized spacecraft. You build a satellite factory. You build a rocket. Oh, did I say you had to design a rocket? You build a rocket, and you launch hundreds or thousands of rockets to get up tens of thousands of satellites. In the future, you'll call up somebody that makes transponders, like Ericsson or Nokia or whoever they are, and say, I want 200,000 transponders, please. You call up a servicing company, maybe Astroscale, ClearSpace, True Anomaly, Starfish, and say, I would like these installed on these cell phone towers, please. You call up a cell phone tower company. Just like in the US, we have American Tower and Crown Castle. Someone will own 500,000 cell phone towers in space. You'll say, I'd like 200,000 slots, transponder slots, for the next 25 years. And within a year, you will have deployed an entire global constellation that will be operational for a fraction of the capex that it would have cost if you had to build spacecraft. That's it. So there's an opportunity to be the cell phone tower company. Crown Castle and American Tower, $100 billion companies because they own cell phone towers. That kind of model. The most exciting ones are almost certainly the ones that I can't imagine. They're going to emerge. Smarter people are going to come up with them. There's huge opportunities right now. So if there's a takeaway, it's go find those opportunities and surprise everybody in the industry by making something exist that no one thought of before.
Thank you. Thank you so much for speaking with me. And it was really lovely talking with you again and also meeting you in person this time. So
it's a pleasure. I look forward to being back in a couple of years and telling you all of the stuff that we've done in that time as well.
Please, I would love to hear it. Thank you. Space Watch out.
If you like these or other episodes of Space Cafe Radio, leave us a rating on your preferred podcast platform. It is the currency of today. And if you want to stay on the pulse of the space industry, please visit our website at www.SpaceWatch.Global and subscribe to our newsletters. And of course, don't forget to become a Space Watcher. I'm Thorsten Kriening, publisher at SpaceWatch.Global, your independent perspective on space.